So now I'm going to move on to question 2. It's also under capital budgeting. So let me read it. So the question says, a company seeks to select one or two mutually exclusive projects. The finance director thinks that the project with higher NPV should be taken, but managing director that the one with higher IRR or internal rate of return should be chosen. Since both projects have the same initial outlay, the cost of capital is 10% and the net after tax cash flows are, so you've been given the cash flows for project X, the cash flows for project Y. And it says the scrap value for project X is 2,000 cedis and project Y is 1,000 cedis. Required: A. Calculate NPV, which is the same as net present value. B. Calculate IRR using 20% alternative rates. C. Justify your choice of project to be undertaken and state whether the finance director or managing director has a valid point. So before, let me just explain the question. So the company wants to undertake an investment, which are two different investments, project X and project Y. But they want to see which one would be better for them to, undertake. So there are two different investments. And then the finance director thinks that the one with the higher NPV should be taken, whilst the managing director is arguing that the one with the IRR or the highest IRR should be taken. And the question is asking us to find the NPV and the IRR and whose point is valid. So let's take a look at it. So the first thing we are going to do is that you have to understand what NPV is. NPV is net present value. What that means is that it accounts for time value of money. Meaning that if, let's say, in year 1, you are going to get 20,000 cedis, year 2, 30,000 cedis, year 3, 30,000 cedis, year 4, 100,000 cedis, year 5, whatever cash flow you are going to get, it changes all those future values to present values. You know that those future values are not the same as today's money. Meaning that 30,000 cedis next 5 years is not the same as 30,000 cedis today. So the job of net present value is to show us the present values to see if the investment is good right now, not the future values. So all the values here, the values you have in year 1, year 2, year 3, year 4, we're going to bring them to the present value so that we'll see how much you are getting now. Yes, so now let's start. So let's write what we have here. So we have the year, then 0, 1, 2, 3, 4, 5. So you know what? Let's start with the NPV of project X. Then after we go to the NPV of project Y. So I'm going to do all of them at the same time. But we'll start with the project X. So for project X, let me do it the cash flow of project S. So cash flow into bracket X. And here is 0, 0, 0. So we have 200. Then year 1, let me just do it like this. So year 1, we have 30. Year 2, we have 85. Year 3, we have 95. Year 3, we have 95. Year 4, we have 70. And year 5, we have 18. So these are the cash flows for project X. So let me just extend it. So we're going to do both X and Y. I will start with the X. So these are the cash flows for project X. Now, the job of NPV is to change all these values to the present value. So we'll know how much the investment is worth now. And the first thing we are going to do is to find the discount factor. The discount factor is what you are going to use to multiply the cash flows to get the present value. And a lot of people have challenges with the discount factor and everything. Now, let me explain it. Now, in time value of money, the formula for present value is future value over 1 plus r exponent n. Here's the formula for present value. It can also mean that the present value is equal to, if you bring this one up, according to indices, it's going to be future value into brackets 1 plus r exponent negative n. Once this one comes to the top, the exponent becomes negative. I'm sure you guys remember that from indices. Now, the FV and the 1 plus r exponent n are two different things. The FV is the future value. The 1 plus r exponent negative n is called the discount factor. Meaning that when you multiply the discount factor by the future value, you are going to get the present value. You get it? So without multiplying the future values, which are here, by the discount factor, you can't get the present value. So the first thing we're going to find is this part, which is the discount factor. This part is called the discount factor. We can do a DF, which is 1 plus R exponent negative n. So let's do it. So we have, so yeah, I'm sure you guys understand it now. So let's erase everything. So we have DF. And the discount factor is based on the rate that is given to you. So in the question, they're always going to give you a rate. And what rate did they give us? So they said the cost of capital is 10%. Meaning that the rate you are going to use is 10%. So if they give you the cost of capital as 15%, you are going to use that. If it's 20%, you are going to use that for the discount factor. So since it's 10%, it's going to be 1 plus the rate, which is 10%. But since you are doing business finance, it is going to be the rate over 100. In business finance, anytime you see rate and you're calculating it, it's going to be over 100. It's going to be 10 over 100. And when you do that, it's going to be 0.1. So it's going to be 1 plus 0.1 exponent negative n. Negative n is the number of years. So if it's 2, exponent negative 2. If you're in the third year, exponent negative 3. Fourth year, exponent negative 4. That's what it means. So now, for year 0, and I want you guys to understand something. Anytime you see year 0 in investment appraisal or capital budgeting, it means that's the money that was invested. So this 200 is not part of the cash flow. And this 200 is invested now. What that means is that this 200 is the only value that is in present value. You get it? The rest are all future values, but we are now investing it. So this one is present. So the discount factor is going to be 1. So that when you multiply 200 by 1, you are going to get the same 200. It's not supposed to be changed. Even if you do it year 0, assuming we want to do 1 plus 0.1, which is the cost of capital, exponent negative 0, we are going to get 1. So it's the same thing. So this one, the discount factor for year 0 is always 1. Just keep it in your head. Anytime you see year 0 is 1, and that's the amount of money you're investing. Now, for year 1, it's going to be 1 plus R. So 1 plus R, which is 10%. They say the cost of capital is 10%. It's going to be 10 over 100. So 10 over 100 is 0.1. So the R is going to change from 10% to 0.1. So 1 plus 0.1 explains the number of years, which is 1. But it's negative, so negative 1. Then for year 2 is going to be 1 plus 0.1 explains negative 2. Same for year 3, 1 plus 0.1 explains negative 3. Then you repeat for year 4, 1 plus 0.1 explains negative 4. Then year 5, 1 plus 0.1 explains negative 5. So if it's year 16, 1 plus 0.1 explains negative 16. You just put negative at the year place. So let's start with this one. So 1 plus 0.1 exponent negative 1. We are getting 0.9. 0.9. Then next one, we have 1 plus 0.1 exponent negative 2. We are getting 0.826. So we can do 0.83. 0.83. Then for year 3, we are getting 1 plus 0.1 exponent negative 3. We are getting 0.75. 0.75. Then year 4, we are getting 1 plus 0.1 exponent negative 4. Then we are getting 0.68. 0.68. Then year 5, we are getting 1 plus 0.1 exponent negative 5. We are getting 0.62. 0.62. So these are the discount factors for Project X. And it's also going to be the same for Project Y, because Project X and Project Y are going to use the same rate. So you also multiply this by Project Y values and this by Project. So when you multiply these discount factors by the cash flows of X, you are going to get the present values. All these are future values. So you are going to get the present values. So now let's do it. So we have, okay, let me clean this one since I believe you guys understand it. So now the next thing we find is the discounted cash flow. The discounted cash flow is the same as the present values, meaning all these values in present day or present money. Now, the first one is 200. 200 times 1 is 200. So we put it in brackets. So this amount is already year 0, so it's already in present value. So that one is always the amount, you don't change it. Now, year 1 is going to be 30 times 0.9. So the discounted cash flow is the cash flow times the discount factor. The discounted cash flow is the cash flow times the discount factor. So you have 30 times 0.9. So 30 times 0.9. 27. So it means right now the 30 cedis will be 27 cedis. 30 cedis in year 1, which is the next year, but present day is going to be 27. Then the next year is 85 times 0.83. So 85 times 0.83. We're getting 70.55. 70.55. But that means that this 85 in present day is 70.55. And we have 95 times 0.75. You're getting 71.25. 71.25. Then we have 70 times 0.68. So 70 times 0.68. We have 47.6. 47.6. Then we have 18 times 0.62. 18 times 0.62. We have 11.16 or 11.16. So these are the values you are getting, the present values or the discounted cash flows. And I want to mention that depending on your discount factor, if you do, for example, the year 1, yours might be 0.90 something, 9091 or something. Your own might be a little different. So you might get 27 point something or 26 point something. It's the same. You'll be marked correctly. Once it's close to it. So your values might be slightly different, but it shouldn't be too much. You shouldn't get maybe anything more than 71 or anything more than 72 or anything less than 60. It should be around this, depending on the approximations. So yeah, so these are the discounted cash flows. And now you are supposed to find the net present value. And the net present value is the summation of all the cash flows minus the 200 which you invested. So these are the cash flows that you got, and you want to see if it's a good investment or not. So we have to add all the cash flows and remove the costs. So I will see how much you're actually getting right now, like presently. So when we add all of them, so we start from 27 plus 70.55 plus 71.25 plus 47.6 plus 11.16. We are getting 227.56. So 227.56. 227.56. Then you subtract it from the 200, the one in brackets. So anytime you see anything in brackets, you always subtract it. So minus 200. And when we do that, we are getting 227.56 minus 200. So 27.56, which is our net present value of investment X. That's how you always find the net present value. You add all the cash flows, the ones in the present value, minus the initial costs, then get the net present value. So now let's go to the values of project Y. So for project Y, okay, so the question actually gave us a scrap value. I just noticed that the question gave us a scrap value. And the question says for project X, the scrap value is 2,000. And project Y, it is 1,000 cedis. So the 000 you see here means all this is supposed to be 200,000, 30,000, 85,000, 95,000. So you can also do the same. You get a similar thing. You might be getting something. But then if the question gives you a scrap value, the scrap value is the value you get at the end of its useful life. And at the end of its useful life is year 5. You get it? So now, since the question has given us a scrap value, we'll add the scrap value to the cash flow at the end of year 5. Because the scrap value is how much you are getting at the end of the year. After you finish using your assets, how much is it worth? Or how much can you sell it? So for project X, you see the scrap value is 2,000. So plus 2. The 000 already accounts for the 1,000. So 18 plus 2. So now this one is going to change to 20 because of the scrap value. And for project Y to 1,000, okay, we've not done for project Y yet. So now we are going to change our calculation. So it's now going to be 20 times 0.62. So 20 times 0.62, which is 12.4. 12.4. So now to get the discounted cash flow, we'll just add all these values minus the 200. Since now we've added a scrap value, so we'll be getting something around 29 because we had about 2 more. So we can even add, but let's just calculate. So we have 27 plus 70.55 plus 71.25 plus 47.6 plus 12.4. Okay, you have 228.8. So 228. So here it's going to change to 228. 228.8 minus 200. So let's do 228.8 minus 200. 28.8. So now our NPV is 28.8. So we added all this minus the 200. So guys, please don't forget. So anytime you always have to read the question to see if there's a scrap value. If there's a scrap value, you add it to the year 5, the cash flow that is there. Then you find the present value. If you don't add a scrap value, you are going to be wrong. You get it? So always add the scrap value. So since the scrap value is 2000, which here will be 2, so you add it to this one to get your actual net present value. So now we can proceed to calculate the net present value of project Y. So we can just continue with it. So for project Y, let me do a cash flow of Y. It's also 1000. So we have 218. No, okay, sorry, we also invested 200 as well. Then we have 218 for year 1. Then for year 2, we have 10. Then year 3, you have another 10. Then year 4, we have 4. Then year 5, we have 2. And also for project Y, they gave us a scrap value of 1000. So plus 1. All these are 0, 0, 0. So here is 200,000, 280. You also do it the same way. You get the same answer or slightly different. But then, yeah, so plus 1. The 1000, the 0, 0, 0 is already here. So you add the scrap value to the year 5. Whatever you are getting, if they give you a scrap value, you add it to it. So now it changes from 2 plus 1 to 3. Just like we did here. So now we are going to find the discounted cash flow. We've already found the discount factor, which was 10%. So we are going to use the same rate. So for the discounted cash flow, it's going to be this, just like we did. So this times the discount factor, this times the discount factor, because we are using the same rate. So 200 by 1, we are getting the same 200, just like we got here. Then now it's going to be 0.9 times 218. So 0.9 times 218. 0.9 times 218. 196.2. 196.2. So for year 1, we actually got 218 for the project Y, but then in present day, it is 196.2. Then 10 times 0.83. 10 times 0.83. 10 times 0.83. We are getting 8.3. 8.3. Then we have 10 times 0.75. 10 times 0.75. We have 7.5. And we have 4 times 0.68. So 4 times 0.68. We have 2.72. 2.72. Then the last one, we have 3. Because 2 plus 1, we added the scrap value. So 3 times the discount factor, which is 0.62. So 3 times 0.62. We're getting 1.86. So these are the present values for investment Y. And now, to calculate the net present value, I'm going to add all the cash flows minus how much we invested, which is 200. The 200 is going to be in brackets. So anytime you see it in brackets, it means how much you invested. The one in year 0 is always how much you invested. So you invested 200, you invested 200, you invested 200. So it's going to be 196.2 plus 8.3 plus 7.5 plus 27.2 plus 1.86. So when we add all the cash flows, we are getting 216.58. So the net present value of Y is 216.58 minus how much you invested, which is 200. So 216.58. So 216.58 minus 200. I get in 16.58. 16.58. So our net present value for project X was 28.8, and our net present value for project Y is 16.58. That's what it means. So now I'm done with the A part of the question, which is calculate the NPV. So you do it for both investments. So we are done with the A. Now the B says we should calculate the IRR using a 20% alternative rate. So this one, they've given the alternative rate. Assuming they asked you to calculate for the IRR and they didn't give you the rate, you have to take anything higher than 10%. The thing is that for the IRR, the internal rate of return, you need two rates. You need a rate that will give you a positive value and a rate that will give you a negative value. And when you use a rate and get a positive value like this one, you take a higher rate so that you get a negative value, because the IRR is where the NPV is equal to 0. So since they said we should use 20%, we are going to calculate all this again using 20%. So let's write the values at the top so that we don't forget. So NPV of X is equal to 28.8. Then NPV for Y is equal to 16.58. So this one, our rate was 10%. Our rate was 10%. So now we are going to find another NPV for them using 20%. We use 10%. Now we're going to find another rate for them using 20%. So now it's no more 10%. So here, the discount factor, we did a 1 plus 0.1, 1 plus 0. Now it's going to be 0.2 because 20 over 100. Our new rate is 20. So for this one, we are going to claim here 0. So 0.1, 0.1. So it's now going to be 0.2, 0.2, 0.2, 0.2, 0.2. Then, and the values are going to be different. So we are going to claim so the discount factor is still going to be remaining 1. Even if you're using 30%, 100%, whatever, the discount factor for year 0 is going to be 1. So that one doesn't change. So now let's find our new discount factor using 20%. So we have 1 plus 0.2 exponent negative 1. Then we have 0.83. So 0.83. 0.83. Then we have 1 plus 0.2 exponent negative 2. You have 0.694. 0.6. And so let me do a 0.7. Or let me just maintain the 0.694. Therefore, year 3, 1 plus 0.2 exponent negative 3. You have 0.578. So more like 0.579. So 0.579. Then for year 4, we have 1 plus 0.2 exponent negative 4. So 1 plus 0.2 exponent negative 4. We have 0.482. 0.482. 0.482. Then year 5, we have 1 plus 0.2 exponent negative 5. 1 plus 0.2 exponent negative 5. We're getting 0.4. So 0.4. Now we are done with our discount factor using 20%. So let me put a 20% here. The first one, I used 10%. That's why we got 0.1, 10 over 100. This time 20%, so 20 over 100, then we get 0.2. So to get our discounted cash flow, we'll multiply this by this, just like we did. So we're going to get different values. So let me just erase everything. So the discount factor is going to remain the same for year 0. Then for year 1, it's going to be 30 times 0.83. So the discounted cash flow is always the discount factor by the cash flow, which will give us the present value. So we have 0.83 times 30. 0.83 times 30. We have 24.9. 24.9. And we have 85 times 0.694. 85 times 0.694. 58.99. 58.99, which is this times this. Then you have 95 times 0.579. So 95 times 0.579. And we have 55.005. Then we have 70 times 0.482. So 70 times 0.482. And we have 33.74. 33.74. Then we have 20 times 0.4. So 20 times 0.4. I'm getting 8. So these are the present values for project X using the discount factor 20% or using a rate of 20%. That's what it means. Yes. So now to get the NPV of project X using the discount factor at 20%, the first one you use 10%. So let me just put the rate here so I don't get confused. So this is 10%. So now using 20%, let me write it here. So using 20%, the NPV, we're going to add all this, then minus this one, the 200. So we take the cost from it. So it's going to be 24.9 plus 58.99 plus 55.005 plus 33.74 plus 8. We are getting 180.635. So we have for project X is going to be NPV for project X is equal to 180.635 minus the 200, which is the cost, minus 200. So we are getting, so 180.635 minus 200, 180.635 minus 200. We are getting negative 19.635, negative 19.365. So that's for project X using the rate of 20%. Now we are going to go to project Y. So let's clean the values as well. So, okay, the cash flows are the same, only the discounted cash flow is going to be different. So clean. So okay. So for project Y, we are also going to multiply the cash flows by the discount factor since it's all 20%. So it's going to be 218 times 0.83. So 218 times 0.83. 218 times 0.83. We are getting 180.94. 180.94. Then the next one is 10 times 0.694. So 10 times 0.694. I'm getting 6.94. 6.94. And get 10 times 0.579. So 10 times 0.579. I'm getting 5.79. 5.79. And we have 0.482 times 4. So 0.482 times 4. 0.482. Where is it, class? 0.482 times 4. So 1.928. 1.928. Then for the last one, we have 3 times 0.4. 3 times 0.4, which should be 1.2. 1.2. So these are the present values of project Y, how much you're actually going to get in present day. So similarly, we are going to add all of them, all the cash flows minus the cost, which is 200. So let me do it here. So NPV of Y is equal to 180. So we add all the cash flows from 180.94. So 180.94 plus 6.94 plus 6.94 plus 5.79 plus 5.79 plus 1.928 plus 1.928 plus 1.2 plus 1.2. We are getting 196.798. 196.798. So now we do 196.798 minus the 200. So 196.798 minus 200. We are getting negative 3.2. So minus the 200. Minus the 200. So you are getting negative 3.2. You are getting negative 3.2. So because I rounded it, you might get something different. So you might get negative 2 or negative 4 or something. For here, you might get negative 18 or negative 20. Similarly, here too, you might get maybe 29, 30, or 27. Here you might get 17 or 15. It's all the same because of approximation. So yes. So now we have the net present value of X using 20%, net present value of Y using 20%. Then we have the net present value of X using 10% and the net present value of Y using 10%. So now we have the net present values of both of the investments. For project X, we have the two net present values we need. We have 20% and 10%. And for project Y, we have the two net present values. So for 20% and 10%. And I said to find the internal rate of return, you need two net present values. You need one that is positive and one that is negative. So for project X, this is the one that is positive, 28.8. And for project X, today is the one that is negative, negative 19.365. For project Y, today is the one that is negative and this is the one that is positive. So now we have both net present values. So now we can find the internal rate of return. So let's clean this side since you are done with the net present value. So so these are the net present values. So here is 10%. Yes. So now the formula for the internal rate of return, we are using the internal rate of the formula is IRR is equal to, so we have A plus net present value of A over net present value of A minus net present value of B times B minus A. This formula is also called the linear interpolation formula. Now let me explain. The A here is the rate that gives you the positive value. So you can write it down if you want. The A is the rate that gives you the positive value. And when you use the rate that gives you the positive value, the NPV A becomes the positive NPV. You get it? Then the rate that gives the negative value is the B. So the negative NPV becomes the NPVB. So you realize that here too, for example, this 20% give us the negative 19. So it means the rate that gives us the negative 19 for project X becomes the B. You get it? So now let's do it for project X so that we understand. So IRR for project X is equal to, so I said the A, so now we are dealing with project X. So the A is the rate that gives you the positive value. So for project X, the rate that gives us the positive value, which is 28.8, is 10%. So that rate now becomes 10 plus then NPV of A. So the 10% give us 28.8. So what the 10% give us, which is 8.8, then over NPV of A again, so 28.8 again, then minus NPV of B. So NPV of B is the negative rate. The negative rate. The NPV of A is the positive one. The NPV of B is the negative rate. So what's the negative rate of X? So where is it? So here, yes, right here, negative 19.365. So since it's negative, so negative 19.365 times B minus A. B is the rate that gives us the negative. So the rate that gives us the negative for X is 20%. So 20. Then A is the rate that gives us the positive. So that's 10%. That gives us the positive. So minus 10. So this is what you are going to get for the IRR. So when we punch everything on the calculator, we are getting 10 plus 28.8 over 28.8 minus into bracket negative 19.365 and then close bracket times into bracket 20 minus 10. 20 minus 10. And they are getting 15.97. I say it's more like 16%. So you are getting 16%. The internal rate of return is obviously calculated in percentage because it's a rate. So 16%. So for the internal rate of return for X, you are going to get 16%. You get it? For the internal rate of return. So let me just write it here. So IRR for X is 16%. And so yours might be very close, maybe 15 point something or 17 point something. It will also be accepted so far as you go through the correct procedures. Now let's do it for Y. So for Y, it's going to be the same thing. So I said A is the rate that gives you the positive value. So let me change it to IRR of Y. So for Y, what rate gives us the positive? So where is the NPV of Y? This one is the positive one, and that one to 10% give us the positive value. So the A will be 10 plus the NPV of A. So what the 10% gave us was 16.58. 16.58, which is the positive NPV. So the positive NPV is the NPVA, then over NPVA again, which is 16.58, then minus NPV of B, which is a negative NPV. So since you are dealing with Y, the negative NPV is negative 3.2. You get it right here, negative 3.2. So into brackets, negative 3.2 times B minus A. So B is the negative rate, or the rate that give us the negative NPV. So the rate that give us the negative NPV is 20%. 20% is what give us the negative 3.2. So 20%. Then minus the A, the rate that give us the positive one, which is 10%. That give us the positive, so 10. So I'm going to punch this on the calculator and see what you get. So we have 10 plus 16.58 over 16.58 minus into bracket negative 3.2 times into bracket 20 minus 10. So we are getting 18.38%. So 18.38%. So this is our IRR for Y, or the internal rate of return for Y. So always in percentage. So for the internal rate of return for Y, we are getting 18%. So now let's realize something. For the net present value of X, we got 28.8. The net present value of Y, we got 16.58. So meaning that for the net present value, X was higher. So if we wanted to use the net present value, we would have gone for X. But for the internal rate of return, the Y was higher. The Y was 18% and the X was 16%. And the C further on goes on to say, justify your choice of project to be undertaken and state whether the finance director or managing director has a valid point. So for this one, it's not really direct to the question. It's just a general question. Because the finance director was saying that the one with the higher NPV should be taken. But the managing director was saying the one with the highest IRR should be taken. So right now, they are just saying NPV and IRR. Which one is a better measure when you are calculating investments? And it is obviously net present value. Because, so this one, they are going to say it is the finance director because he chose net present value. And the reason is that the net present value is a better measurement when it comes to profitability. And the reason is that the net present value actually gives you the actual returns you are going to get. Do you get it? The net present value, you got 28%. That one is the actual returns in terms of money, what you are going to get, the present value right now. But the internal rate of return just gives you a percentage. It's where the NPV is equal to 0. So that one doesn't really tell you the returns you are going to get. It just gives you a percentage, more like an estimate. Do you get it? So for the C, you can just go ahead and see that the finance director has a valid point because the NPV is a better measurement when it comes to investment appraisal. Simply because it actually gives you the actual returns you are going to get, not a percentage. Percentage is an approximation, but the NPV gives you the actual returns. That's all. So that's for question 2. So now we are going to move on to question 3, which is also on capital budgeting. It's funny how a lot of questions are from capital budgeting. And for this year, I'm actually expecting a lot of questions from capital budgeting. So if not, at least one of them. So please, you guys, I'm begging you, please take this topic very serious. Please take it very serious. So let's move on to the third question.